I'm sure the adds probably 150 megs. Yeah, that's probably true.
How big is it?
What's this? I have a folder on the H drive now.
What like the size?
I knew we had a storage space.
Dude, I think when you landscape their building,
Yeah.
Just showed up for my, maybe faculty.
I can remember.
Just got something on there.
I don't use computers anymore since I have
Yeah.
That has a little more.
Revit on my computer, so it's best when these computers, you don't know if they're gonna work or not.
I don't
I'm
know.
trying to, I have to. I feel like I'm trying to make this project inclusive. I'm not talking about data patterns.
I know exactly what you're talking about.
And I'm not necessarily comparing myself to my own.
I think,
Well, I'm saying that the significance of this work is not what it was. Yeah, I'm saying that the significance within his overrun is the same. But it's.
When, how'd it go? Or critical mass? Everybody liked it?
Fantastic.
You never want to see it. It's quite the
That was my only complaint.
I tried to make
Hey Jeremy, the other day when we talked, I guess it was last Tuesday, we were talking about kind of, you don't need more than one stair for a certain amount of floors. Do we know how many floors? Because I have, I think, 5 or 6 levels that go up past the top, where the 2 stairs won't work, so I have to put a 3rd stair in just for that top few floors.
Somewhere in the code, and I know the exact number at the moment, but they allow, and probably not for skyscrapers, but what I was thinking is there are certain buildings that you can have one egress if you don't have more than, let's say 30 people. Yeah. You can allow them to go down one stair. Like all of that is like.
Same exact thing.
Yeah, a couple on each I mean, I'm not gonna be checking.
Well, I just didn't want to have 2 stairs going all the way up there, because it would
Yeah, I would just do
kind of take
one.
away floor space there.
Yeah, I would.
I had to learn how to.
Here's a playroom for the kids.
All right.
No rails.
Did everyone get to go to critical mass and see the lecture and all the different presentations? All right, good. I thought that would be a much needed break, plus it was going to be hard to get a lot of content in after the lecture. You know, everyone would straggle in, and we'd probably have like a half hour to go over some stuff, and that's not a lot of time to really cover things in Revit. So wanted to make sure you guys also had some working time, so hopefully you guys made a little more progress on your hotels. Anyone put in a pool yet?
Put in the hole for the pool.
Put in a hole, all right.
I couldn't get the floor to change colors. I changed the material. They said it was changed, but.
If you're gonna get a appearance, so actually like a void and the
That's
walls
what-
for it, but if you're gonna get appearance.
So like a sloping bottom.
I didn't slope, it's pretty deep.
I
Okay.
couldn't get the slip to work either. I think I just.
All right. Well, today,
It's like 15 feet deep.
so like a little
Okay, I can go in the pool. I was on the pool.
That's all right. So basically, today what I want to go over is, you know, we started talking about ceilings a little bit, kind of just the basics, the last class, but I want to go into some more complexity on ceilings, how we could actually deal with sloped ceilings, and then, you know, actually putting lights into a ceiling structure. In addition to that, looking at floor slabs, because they kind of relate to the same way that the ceilings work out. You know, especially when we get into pool design, you might have a shallow end versus a deep end, and there might be some opportunities to work with sloped floors. And then another topic I want to go over is roofs, and get into some things like sloped glazing. because we've gone over kind of some basics of the roofs, but we can deal with, there might be some opportunities within your hotel to not only put in a roof over a certain part, but we might be able to apply a sloped glazing structure or some kind of skylight system. That might be a nice feature as well. So basically today, I think if we just start with a new project, and we can just kind of do some examples in the new project environment, that'll keep things kind of light on the processor side. So I've just started a new project, and kind of the last part that I went over was just putting in your basic ceiling structure. We want to start looking at how we can work with that ceiling a little bit more, and so that you don't just always have to put in flat ceilings everywhere. I'll kind of go over a quick recap. I might draw just some walls, and I'll make a rectangle, just a rectangular space, and then I think in the other example I just had kind of an open space like that. Now when we're dealing with ceilings, again, when we click on the ceiling, Revit comes with our 2x2 ceiling system, our 2x4, which is a gridded system, and then also a chipboard on metal stud ceiling. And if we were to draw with just the chipboard on metal stud, I'm going to use the sketch option to create a ceiling, and I will just kind of make a kind of a curved ceiling in plan here. Just had a kind of a curved soffit last time. And had something that looked like kind of this little wedge off to the side. Once that's closed, we can close out of that. And of course, I drew that in a floor plan view, so I'm not going to see it until I look at it in a ceiling plan. So to always remember, sometimes you can draw ceilings and floor plans and also ceilings. But if you want to actually see that ceiling system, we need to be in a reflected ceiling plan. I'm going to cut a section through the ceiling, looking at it in two different directions. So I'll create one section, a cross section, and a longitudinal section. And then also, because we created a new project environment, we don't have our 3D view. So I'm going to create a 3D view into our project browser. Now, right now I've drawn this ceiling, and I just used the default. If you select the ceiling, I drew it at 8 feet. I might move that up to be something more like 10 feet. And what I went over at the last class was, that's the basics of ceilings. Are, we can create any kind of horizontal plane and adjust it based on a bottom level constraint. So right now I'm on level 1, and then we can always enter in whatever height we want that ceiling to be from the floor. But if you're in, especially like let's say a large lobby space or any kind of large space, we might want to design some other options into the ceiling, so you just don't have a flat plane that's going on forever, in that space, and it's only set to like 10 feet. So with the ceiling plane, we have a couple different options of how we can deal with additional ceilings. The first thing I'm just going to go over is looking at a sloped ceiling. I went back into I had set that to a level 10, and by default our level 1 and level 2, our level 2 set to like 10 feet. I'm going to go ahead and move that up to 15 feet, so when I look at my reflected ceiling plan at level 1, I can actually see my ceiling again. So I'm looking at this ceiling. It doesn't matter what kind you drew, if it was a gridded ceiling or your chipboard. But what I'm going to do is slope the ceiling in one direction at least. And whenever we've drawn a ceiling, we can once you've drawn it, it's kind of best to get the plan shape done first. And so I've just drawn the plan shape and then set a base height of where you want that ceiling to start. But we can go back into the ceiling and click on Edit Boundary. And we've gone over this, I think, before on a couple other labs, but we've got a slope arrow as an option to actually begin to slope our different ceiling planes that we're working with. So if we click on slope arrow, it gives you the ability to draw a line or pick a line. I'm just going to use the draw line option, and I might draw a line from left to right. And by drawing this line, the slope arrow, we're basically just applying exactly where our slope is going to occur. And if you select the slope arrow by left clicking on it, and you look over at the properties to the left, you get a level at the tail and level at the head. So at the tail and the head is where the arrow is located. That will be the offset from the ceiling plane that we've already established. So if we've already established a 10-foot height from level 1, if we were to keep the offset at 0, that part of the ceiling will remain at that level 10 foot. So then to figure out where you want it to slope, you're basically identifying at the head or the tail how far up or down you want the slope to occur from that level 10 plane or that 10-foot plane. So I'm going to do something a little bit more drastic at the height at the offset at level at tail. I'm going to type in 10 foot, and I'll keep the other one at 0. And if I exit out of this and then look at it in 3D, you'll see how you can get your ceiling to begin to slope instead of just being a typical horizontal plane. We can start to add in a little bit more spatial conditions into our ceiling plane. Another thing that we could do is back in our sketch, if I go back and edit the boundary, I can actually also create I can do more than one slope arrow. So I could have a slope arrow that goes to a certain point, and then if actually no, I can't. We go back to that level again. I guess if you wanted your ceiling to break into a couple different pieces and then have it slope in multiple ways, I would probably do a couple things. Is you'd have to edit this, and you'd want 2 closed ceiling planes. And since I already have a shape here, I'm just going to select all of this and hit copy to clipboard for a moment. And then I'm going to draw a line where I want this ceiling to stop. And I can actually come back here and trim and extend all of my points. And then make sure my additional ceiling line that I had off to the far right, I delete that. I can exit out of that. And then because I did a copy and paste, I could go back to home and then ceiling, create a sketch ceiling again, and paste align to current view. And it brings in all that sketched elements again, and I could go ahead and flip. I'm basically making another ceiling, but I'm maintaining my shape that I already created. And so by copying and pasting your sketch elements, that allows you to make that kind of edit eventually. And I could actually make sure this is set to 10 feet. And I'll keep that the same too, and look at it in 3D and see what I've got. And so you can bring a couple different ceiling planes together. And so I've got even a curved shape in the plan view. And then when you look up at my screen, I've got kind of this down arrow or this V-shaped ceiling system. I'm going to do a save as here real quick. Now the other part to working with ceilings is so far I've also just looked at editing the boundary, and I've got my slope arrow always kind of parallel to a particular edge. But we can actually also take this slope arrow, and it doesn't have to be parallel. You could have a slope that goes across some particular degrees, and you're basically just telling the plane which way you want it to slope. So you can always rotate that slope arrow, and we can close out of that and also look at our 3D view as well, and you can start to see how you can adjust the slope and change the direction of it just by moving that slope arrow around in different locations. So again, I could just draw another one if I wanted to, or I could continue to play with how I want this slope arrow to occur. And with each change of maneuvering that slope arrow, you're changing exactly how that plane is going to slope across the distance. Now, a lot of you have said in the past or asked questions, whether it's in this class or from other classes, that if you do have a set of conditions where basically we've got these different sloping planes, these different ceilings that are coming across, and we want to find a way to close the gap in between. And when we get to those type of conditions, what we want to do is look at what would you actually do in the real world if you're constructing this. You would build a vertical soffit wall that would connect one ceiling plane to the other in order to close that gap. And so sometimes your ceilings are composed of, and even your roof structures might be composed of a series of horizontal planes, which might be your ceilings and your roof structures, but also combined with a wall structure of some sort to close off the gap. In order to make that happen, what we need is the ability for our wall to extend to the base of a structure, a horizontal plane. I'm going to call it a horizontal plane even though we're sloping it, but a horizontal plane type of tool. And we need a base constraint and we need a top constraint. We need a way to attach the top of the wall to that system as well. So what you need to do in a case like that, if we were actually trying to close off this particular gap that you see, is we want one of our planes or both of our planes to overlap each other in plan. And this would be a time where you might look at a site view, and I think in my visibility graphics I need to turn on ceilings so I can see those. And basically again, our site view that comes with Revit, we're just looking at it from well above and looking all the way down through all the different floor structures. And looking at it in plan, what we can do is select one of our ceiling planes and edit the boundary, and then we can offset. And for right now, I'll do an offset of, let's say, let's just do something like 5 inches. I'll turn off the copy when I do the offset. And when I do the offset, you'll notice that because I had this curved portion at the end, as soon as I did the offset 5 inches, it automatically realized that I wanted to offset, and it automatically extended my curve to meet up with the vertical. So it's kind of a nice feature with Revit, is it always assumes that you want to keep that curve or that angle when you start to do some of these transforms. And by doing this offset, what that allows me to do is now have the ability to attach a wall from the base to the top of these two different systems. And right now what I'll do is just in level 1 floor plan, I'm just going to draw a wall, and I'll do a basic generic 5-inch just for now. And I'm just going to draw, I don't care where it shows up at the moment. I'm just going to draw it in the floor plan view and then look at my site plan. Because I've drawn this wall by default, it's already set to go from level 1 up to level 2, or I might do an unconnected height, do something like 20 feet. And all I'm doing here is I drew a wall first, and now I'm going to position it into place. So I can click on modify, align, and then I'm going to align this wall so that I'm overlapping my two ceiling systems. If I click on them, you can see that I've got this wall exactly where the overlap occurs. Then I can trim and extend, or maybe I might have to, because of the curve, kind of just move that back boundary a little bit. And I'll probably want this wall to exactly be underneath the wall or the ceiling structure on both these locations. Now by drawing that wall, even though I've drawn it where it extends well below and well above the ceiling systems, you pretty much want that to occur, or you could actually have it where it's in between, but it doesn't matter because we're basically selecting that wall and using these two tools that are up at the top. You can select any wall at any time, and you get the attached top and base and also the detached top and base options. If I click on attach top and base, the first thing you'll see that off to the left in the options bar, in that green bar at the top, you have a kind of a bubble next to top and a bubble next to base. That's dictating what you're attaching to the top and what should be the base. So the first part is going to be attach wall to top. I want that selected. And I want to select the horizontal plane, or in this case the ceiling, slope ceiling that I want to be the top. And so you can see that when I hover over any of these horizontal planes, I'm able to select one of them as my top attachment point. This will work with any kind of tool that basically Revit draws as a horizontal plane, or considers a horizontal plane, such as floors, ceilings, and roof structures. So again, I've got attach top and base. I'm attaching my top, and I can select my top ceiling, and you can see how it trims down that wall to automatically meet up with that ceiling. Now I can choose this wall again and choose attach top and base, and the next time I can choose the base bubble instead of the top. And now that I'm selecting how I'm going to attach the base, I can now select the other ceiling structure that's down below, and I actually get a ceiling where I can start to close off that gap in between. So even though I've got these sloping planes, and whether it was done with a roof or a ceiling or a floor tool, you can come up with your own sloped structures without having to deal with attaching it to a mass and coming up with kind of more complex ceiling structures, if you can just use the tools that are already part of the project environment, such as just the slope arrow and then your walls that you can attach to the top and base. And of course, I used a 5-inch generic. I could change that to be a glazed storefront system, and that will take your top mullion and it will actually slope it at both locations, on the top and the bottom. So you can do curtain wall systems in between. So for a lot of you that are doing kind of sawtooth skylight systems in your projects or buildings, or you might have the opportunity to, this would be a method for making that happen. And of course, I used a storefront system. You could use a curtain wall system and then come up with your own mullion spacing or whatever you want to do. But it's kind of a nice quick way to get some daylight into a space. I could get even more complex with this ceiling if I were to look at what else I could do with these structures. And I might be able to cut a hole into this larger opening, and maybe it'll be an opportunity to start to put in a skylight system, and then also deal with a roof structure, and then a sloped glazing skylight that might go into this space as well. I'm going to still model within, I'm going to keep these two kind of complex angles and model within that structure at the moment. So you guys can follow along with whatever examples you have with your slopes as well.
Jeremy, what might be the reason it's giving the error messages when I try to attach a copy to this?
What's the error message say?
It's saying
You need to pull it past it, but then like when I push it back, it takes it away. You can't have to
I
roll
did it past
past it.
it too. Doing the same thing.
Yeah, you really have to make sure it's well past or exactly lined up identical. If you're off by just a slight inch or a quarter inch or something, it's not gonna work. So actually when it looks like,
I had it like.
so actually this, yeah, this, if you select this ceiling, you want that edge to be on this side, and on this ceiling, you want that edge to be on the other side of that wall. So they're
Oh, I
actually
see.
crossing like this on top of
I
the
got
wall. Okay. Anyone else getting error messages? So this ceiling right here, you select it and look at it in the site plan view real quick. Zoom in. You want this edit boundary line, if you click on edit boundary, you want that on that other side. And same thing with the bottom if you're, yeah, just like that. Yeah, so they definitely, the horizontal planes have to exactly overlap. And if you're slightly off, it's not going to allow you to attach. That also goes with, if you see how I've got this wall exactly kind of ending at the back face and also at the front, if I were to extend this wall and move this out beyond the face of the ceiling, you'll see how whatever part wasn't overlapping that ceiling structure will extend back down to whatever your original constraints were for that wall. So let's say I had a unconnected height of 30 feet, and then I had my base was at level 1, whatever the original shape was, if you happen to miss either end of the wall, you're going to get your wall kind of cutting up, back. It's going to extend to the top and the bottom of whatever your original parameters were set at. So it's actually kind of a nice feature sometimes too, if you actually had this wall and we were extending it beyond, and certain parts interacted with the ceiling structure and other parts did not, we can actually get that to trim and extend by having those horizontal planes overlap. Go back to, kind of like that one part right there, so I'll keep that. Okay, so now we can kind of dive into this a little bit more, and I'm just starting to show you even more options of how we can just use the basic project environment to create kind of complex spaces. I'm going to take this ceiling structure that's on my left side, and I'm going to make that into kind of a coffered ceiling where I might punch out a hole and then maybe drop some, extend some walls up a little bit higher, and then we'll do a roof structure and a kind of a pyramid skylight system with using the roof tool. So first thing I'm going to do is establish what my shape of, or what this opening is actually going to be within that ceiling structure. So again, I'm going to look at it from above. I can look at it from below or whatever plan view I want. So I'm just going to edit the boundary and draw within the center kind of this rectangle, but I might want to make it kind of equal. So I'll just make sure I've got like a 14 foot by 14 foot square. Number lock would help. So I've got this kind of cutout in the middle that's going to be 14 foot by 14 foot. And if I exit out of this, you'll see that I still get my sloped ceiling occurring, but now I have that rectangle cut out of it in the center. I could also do that same opening by going to home and using a vertical shaft opening or a vertical opening in that same profile. You can cut out openings in the same manner. I'll keep that at the moment, just like that. And then in the, basically what I want to do is create maybe a flat, I'm going to create like a flat roof structure that I'll punch a hole through, and then we'll do a pyramid structure. So kind of got your interstitial space that would occur, you know, where you might have, you know, some of these, you might have mechanical systems or whatever. And I could actually draw a solid wall on top of this to close that off. So I'm going to take this wall that's off to the left and extend it up 25 feet. So I get kind of a parapet condition. I might do the same thing on the back side. Of course, your examples are going to be a little bit different, but you can improvise. I might establish a roof plan. So I might go into an elevation view and draw another datum marker, just so I can draw a roof at a particular level. Now I'm just going to make this, right now, let's say level 3. And we'll play with the height of it in a little bit. Maybe I'll make it 24 feet and call it roof. The reason I did that is whenever we start to draw a roof in a particular plan, it wants you to establish some kind of datum that's higher than a floor. And because our current model is higher than the second floor, you know, I kind of wanted to work with another level that we don't quite have yet. So that's why I added that particular level. And now I'm going to draw a roof, and a couple things with roofs, and I might just draw this off to the side for a second, because I don't think we've gone into a lot of detail with roofs yet. If I click on roof, we can draw, again, you've got different roof assemblies. And right now I'm just going to draw a generic 9-inch roof. And I'll draw a rectangular, just kind of some kind of rectangle roof off to the side. By default, whenever you draw a roof by boundary lines, you get these angles, these little pitches that are off to the side, little pitch symbols. And these indicate the hinge in which your roof is going to slope. So if you think about this particular parallel edge, if I select this and tell it that it's going to slope at a 912, what it's doing is it's going to take this from the roof plan datum level and start sloping this plane up until it meets all the other planes of the roof system. So it's basically taking a horizontal plane and hinging it about this horizontal or the vertical, and going to start the slope going at whatever direction you create. So if I keep them all at the default, which is 912, and click OK, look at it in 3D, you'll see I get this kind of pyramid structure, a hip roof. I could edit this footprint again, and I can do this in 3D, and I could select the opposite, basically the eaves of the roof, and turn off at the very top of the options bar, I could turn off the define slope. That will make it so that this, whatever I selected, will not be a hinge, it will not be sloping. What that does when I cancel out of that, it creates a gable roof. Or I could edit this and make it so that I only have a slope on one side, and you can get a sloped one-pitched roof. Now, roof structures also work in the same way as ceilings, in that by default Revit assumes that you want one of these horizontal or vertical edges, or whatever particular plane you're drawing on, one of these lines to act as a hinge and actually slope up. But you might want a roof to slope not from one of these horizontal or these parallel edges. So if I uncheck all of the slope, or make sure that all these lines do not define a slope, I also have the ability to use the slope arrow in the roof command as well. And so I could do the same thing that we just did with the ceilings and draw a slope arrow from one side to the other. And then again, I might give this something drastic. Maybe I'll do a 50-foot at one of the levels. And then look at it in 3D, and you can see how you can begin to get another option for sloping your roof structure. I'm going to take off that slope arrow, and I've also got it where I don't have any pitches at all. I don't have any pitched angles. If I click on that, I'm just making it basically a flat roof. Another option for dealing with roof structures, and this also goes the same with floor structures. If you select that structure outside of the sketch boundary or outside of the edit footprint, you'll see that you get these additional options up at the top right that talk about modifying sub-elements, adding points, adding split lines, and picking supports and things like that. This gives you the opportunity to make additional ways of sloping your roof structure by basically putting in either ridges or any kind of spot elevations, if you will, to actually start to slope your roof structure. And again, this applies for floors as well. So I can add a point, and let's say I'm just going to randomly throw in a couple points here into this sketch. And when I do that, I have to click on modify sub-elements, but I can select these points, and you'll see that when I select them, they're set to 0 foot. You get this little number that shows up that says 0 foot. That's showing you that those particular points are going to be associated with the roof plane that we've already established. But I could select one of these points, and again, I selected modify sub-elements in order to get to this part. And then I could click on the text, and I could change this to be something like 2 feet. And maybe I could change this other one to be 4 feet. And I can come up with all these different spot elevations. I can make this one -2 feet. And when I exit out of this and again look at it in 3D, you can see how you can start to, further manipulate a roof structure by dealing with, particular spot elevations. Now what it's going to do is automatically draw ridge lines, in between each of the spot points, because it assumes you're going to have straight planes moving in from point to point. So again, just using the basic Revit tools that are in the part of the roof structure and the floor structures. Again, whatever we just did with the roof, you can also do with the floor. The only difference with floors, you don't get the option to select a pitch. You can't type in a 9/12 pitch or a 12/12 pitch. Kind of your typical roof terminology. So, that's the basics of all the different options you have with the roof. But what I'm going to do is keep it simple over here to the left. I'm just going to draw a flat surface, and then we're going to make a sloped glazing pyramid structure in between, or as our skylight. So I'm going to go back to the site plan. Or actually, I have a roof plan now, so I'm going to draw a roof, be in the roof plan. And I'm going to select roof. And one last thing, if you select the down arrow under roof, you also see that you have a couple other options for drawing roofs. So far we've done everything by roof by footprint. You can also create roofs by extrusions, which would mean you would draw a extrusion, let's say in an elevation view, and we'll do that in a minute. But you can come up with a particular section shape, and it basically will extrude it straight along a particular path. The next part would be a roof by face, and that's where your masses that you've been working on come in. So if you have a sloping mass or a complex mass, you can also apply your roof structure to that. Wait for that to pop up, to that particular curve or whatever you're dealing with your top structure. But again, I'm just going to do roof by footprint. I'm going to keep my generic 9-inch, and I'm going to select all the edges of that ceiling structure that I was working with. And again, I have to make sure that everything is closed, and I'll select everything and make sure that my define slopes is turned off and just keep it flat. Now hit OK. And so maybe I can, I'm I'm gonna go back to my elevation and just change my roof height to be more like 22 feet, just a couple feet down. And because I drew that on the roof plane, it's established with that roof datum line. And so if I move, since I moved that datum line down to 22 feet, my roof plane also moved down as well. There you go, 23 feet works better. Okay. So now I'm going to cut a hole in this roof so we can get our skylight system in there. And I'll do that also by looking at the roof plan. And you can see my roof plan shows an underlay of level 2, so I can actually see the cutout below. And all we need to do is select our horizontal roof structure, and I can edit the footprint. And then also make sure I select basically the edges of the ceiling cutout below, and also make sure that those don't have any kind of slope to them. And now I've got a hole that goes through the roof and also the ceiling, so that whatever structure we put in there, you know, that light will get down to this space down below. So one last thing I might do is close off all of these areas with walls, so that we're actually modeling this how you would actually build it. And again, I'm going to just draw on the roof plan, and I'll just use a generic 5-inch, and I'm going to select all the edges of these lines. And actually, before I select that, I want to make it where it's my finished face exterior is my location line, and then I can actually zoom in and select all of these lines and get them to overlap. I want them to overlap the ceiling and also the roof. You can see when I look in 3D, I'll have something that is boxed out and looks like this. And then I can again use my attach top and bottom, but I might want to select all of these and make sure that my bottom base constraint might be down at level 2. And I'm going to make my unconnected height just something so that I can get my walls to penetrate all the way through, and then it makes it a lot easier for me to attach my top and bottom. And so I can select, and again I'll do the top as the roof, kind of go around and do that with each of these. And I think you might be able to do 2 at a time or more. Yeah, so I could have selected all 4 and done an attached to top and bottom. And I might do the same thing here with the bottom. So I'll select all 4 of these, and then we can attach the base to that ceiling. You see how we start to close off, we're getting that skylight tube to go down through the ceiling, so that when we're looking into space, we actually have walls that are closing off that system. Again, I might do the same thing at the top here real quick. So I'll draw a wall, and I'll select my curve. And I can always draw the wall and then select it and hit the space bar and flip it. So if I happen to not draw it on the right direction, and I can also use the flip arrows. So I made sure I get my curved wall underneath or overlapping again. And then I want to do the same thing with my other wall. I'll select this other edge over here. I'm going to attach the base. I'm just kind of trying to close off. And it didn't like my curved wall for a minute, so let's work with So sometimes you have to, you know, play around a little bit with the wall to make sure it's, you know, a little bit on one side of the overlap. So I kind of adjusted that wall to troubleshoot it a little bit. And I probably have to do the same thing with my curve. I might need to look at the roof, maybe use my arrow commands. Let's see if that would work. It's not liking that curve. So it seems like my end point was causing the problems in both of these. So basically, I played with the position of the end point, and then I'm establishing my top and base. And let me see, now that I've done that, if I go back and join these together, if it will like it. Sometimes it's a little finicky, so that worked. And this other one, maybe I could extend. See if I can extend to the wall. So sometimes you have to, as you can see what I did there, to troubleshoot those two walls that weren't behaving, is that you have to kind of pull back some of the endpoints and also adjust the overlap a little bit. And once you get that set and established where they're attached to the top and the base, you can then go back and trim and extend them together and kind of close that shape off. So you can do your trims and your extends all in 3D if you'd like as well, and it works. And so you can see how I've closed off that into kind of a solid element. If you couldn't get those to work, don't worry about it at the moment. The next part I want to go over is actually dealing with how we can work with sloped glazing, because it gives you a lot of really nice options for adding in different skylight structures. You know, you might have sections over a pool. I don't know what your designs all look like yet, because I'll kind of try to review them as best I can. But if you have like a pool that happens to have an opportunity for a roof structure above it, you know, you might be able to cut in a skylight on top of it. You know, it's always kind of a nice feature if it's an indoor pool, or if you want to do an outdoor pool. You know, you don't obviously need that sloped glazing, but it gives you those options. So I've got this opening. And to work with sloped glazing is basically a roof structure that is turned into a curtain wall panel or a curtain system. And to get to those options, if we go under home and roof, we first want to draw a roof by a boundary line or by footprint. And before you select your roof structure, if you select the down arrow, you'll notice down at the bottom, you have an option there called sloped glazing. So I can pick that, and this is exactly like working with a curtain wall panel, just like we did in one of the classes where we, you know, again working with a vertical wall and then cutting it up and gridding it up into different, different panel sizes and telling it what size, what gets a mullion and what gets glass or whatever. This works in the same manner, but we're working in it with a roof tool. So I can click on sloped glazing and then pick, in this case I might pick the outside lines of wherever that wall occurred, just so I get a little bit of overlap on my roof. And I might, select, and for right now I'll keep all sides of this equal to a 9/12 pitch. When I exit out of this and look at it, I get a pyramid skylight shown in there. And of course I could come back and edit the footprint. I could select all of these at one time and also change my slope over to the left in the properties. So maybe I want these to be a 12/12 pitch instead, get that pyramid to go up a little bit higher. The next part is, basically when you work with sloped glazing, it has just basic properties of glass that's being applied there. If you select your sloped glazing, if I tab over till I can select it, and edit the type, you'll notice that this dialog box looks a little bit familiar. It looks very much exactly the same as when we were working with the curtain wall glazing. You've got options for grid pattern layouts, options for changing the curtain panel. So again, if I had certain curtain panels loaded in here, so I've got a solid, a glaze, and an empty at the moment, we could select that, or if you just keep it as none, it assumes you're putting in glass, I guess. Grid layout is going to be your horizontal and your vertical if you're kind of looking at it in plan view. And it'd be nice if they told you which one was which. You kind of have to experiment which one is going horizontal and which one is vertical when you're looking at it in a particular view. I guess they assume you might have your plans rotated in different ways. But for a grid pattern 1 layout, I could change this to have, let's say, we'll do a maximum spacing of, let's do 4 feet. And I'll do the same thing with the other grid pattern. I'll just say maximum spacing 4 feet. And then what we want to do is establish what type of mullions we're referencing. So if you remember in the curtain wall panel exercise, we actually manipulated the different sizes of a curtain wall profile, a mullion. And once you've done that in your project browser, you have the options here to also select those rectangular or circular mullions. So I might come in here and pick a rectangular 2.5 by 5 inch. And I'll do that on all of the border types and interior type. And again, there's unfortunately no way to globally, select all of these and do it in one swoop. So we kind of have to pick all of these, and we can hit OK. Then you see it, basically draws itself and connects all the mullions together, and you get a pretty quick skylight system that has, pretty much what you would find if you were to buy a kind of off-the-shelf pyramid system. Again, we could modify this a little bit more. So again, I did a pyramid by selecting all the different size and hitting edit footprint. But again, if we started playing with what got a slope and what didn't, you can start to adjust your skylight system into different configurations just by playing with the slope. And each time, because we had mullions created, since we're deleting essentially parts of the skylight system, that's what this error message is that keeps popping up. So you just hit delete. So you can see how you can quickly get a number of different configurations of sloped glazing. So a couple daylighting options here. We did our basic, just a curtain wall panel system that's attaching and getting cut to sloped either floors or ceilings, and then also, putting in a skylight system, punching a hole, and kind of building a system of how you'd actually, start to deal with that skylight system. I'm going to turn mine back into a pyramid. Seems to work pretty good. When I did that, it didn't like my but if I just edit the type and maybe make a couple adjustments real quick. You can see how when I went back after I did all those manipulations and I tried to put it back into a pyramid, it didn't add in my mullions automatically. But if you play with the settings, so trick Revit a little bit to make a couple adjustments and force it to redraw itself, then I can go back and get it back to its original settings that I had. So sometimes, if you can't get your mullions to come back into place or certain things in Revit, by going back and editing, changing a couple parameters and then changing it back will get all those systems to come back together. So the next part I want to get into is interior lighting. since you started building ceiling systems, and I might, in this other space here, for the moment, I'm going to draw a flat ceiling just so we can deal with some lights on the flat surface, and then we'll apply them into our curved surface and our sloping surface and see how they respond. But I'm going to draw a automatic ceiling because I've got a closed system. I've got a closed room, and I'll draw this at I'll just do like a 15-foot high, and I'll make this a 2x2 grid system and put that in there. And I guess my view for level 1, my view range, I'll change it to my primary range and view depth to unlimited, and that should get it where I can see my grid. So again, if you remember working, kind of at the last minute there, we talked about adding in a horizontal ceiling system with a grid. I might not like how this grid got applied, so I could actually select the grid structure and move this over and readjust my grid a little bit so I get a particular spacing that I would like. I think we should go to the class website if you can, and go to so you've got the jrodesign.com Revit, and once you get in and log in, under resources, if you log in and select family downloads, a long time ago I was going to go over this but never got to it. I did put a couple of lighting components or family components on here. So you'll see under lighting there's a ceiling light linear box and a download recessed can. We can download both of those. So I'm going to select each of these and do a save as. And put them somewhere where we can get to them. So the first thing I want to do is kind of open these lights up in the family editor and start to look at properties of light and how Revit treats all lighting that you can essentially bring in from either Autodesk Seek or what comes with Revit. Again, if we go to View, User Interface, or Recent Files, and open up a family, by default, Revit does come with some basic lighting fixtures. So you can kind of scroll through those families. Not all of them are ideal, but what a lot of lighting manufacturers are doing nowadays is you can go to websites like Versa Lighting, and they have their whole complete line of lighting modeled in Revit, and you can download all of their lights, and so you get all of their different designs that they have, their pendants, their wall sconces, whatever the different wall type or the lighting types are, and they also have them adjusted to their photometric qualities and have the exact real photometrics built into each of the lighting systems. So it's kind of nice. You can start searching around the web and find some kind of nice designs, and then you can load those into your project, and you get those modeled and so on. But these two that we downloaded from the class website are kind of basic. But when we open them, I'll go to browse to where I've downloaded each of them. And again, I'm opening this through the family editor. Oops. And the first one I'm going to open is the light linear box. And if I look at that, you'll see that, again, we're in the family environment. So you see kind of some of these options that we've dealt with before, kind of basic extrusions and 3D parts and pieces that we can do. And I'm going to get into a class on just generic modeling, and then also modeling, like windows and things like that I don't think we've done in this class yet, to really explore these other additional 3D modeling tools. But basically, all families are modeled with a set of extruded elements. And a lighting component comes with a light source definition. So if you kind of hover around and you see in the 3D view, you kind of see that yellow globe that you can select, a little wireframe. If you select that, you get this option here that's called light source definition. When you click on that, this is where the light source is defined. And so you can change the shape of how the light is emitting from the source and what the light distribution shape is. So kind of this would be like if you were in V-Ray or Rhino or 3D Studio Max, when you start to place lights in a program, you define whether it's like an omni or a linear box or kind of a spotlight or something like that. You can actually change. You can see when I click on them, the different emitting shapes and sources, and then what the different definitions are. So I could do a particular shape that shines up and down, one that only shines down, do more of a spotlight, or do kind of a more scattered dispersed light definition. You can see how I can change what the actual emit shape would be. The emit shape would be, when you look at the light, that's kind of the glow that you'll eventually see. I'm going to cancel out of that because I really don't want to change any of those properties. But the other part is looking at the properties, the family types. All lights come with a very complex kind of preset definitions. And this is something that you'd probably like to get from your lighting manufacturer because they're the ones who are going to know more about what the light loss factor is, the initial intensity, the initial color, all the photometric qualities of that light. They would have that set within this box. But by default, Revit comes with your photometric capabilities and different data that you can enter. But the other part of it is you can see I've got a light source symbol size, a box length, and a box width defined. And that is because if I look at this in a ceiling plan view, you can see that when I look at my family types again, up at the name, I have a couple different shapes already in there. I have a 1 foot by 4 foot shape, a 2 by 2, so I can apply. And with each one of these, with one model, I'm changing this particular fixture into different lighting configurations. And again, that's where our knowledge of parameters come in. Basically, when this light fixture was built, particular extrusions were built to have a box width and a box length that we could change and manipulate just by changing a couple different parameters. So that comes in handy so that one light type can have all these different shapes that you would find. The other part would be, you can actually get into, if you really, really want to play with all the photometric qualities of this light, you can click in here and change all these different definitions. But to me, there's no reason or need to have the ability to do this in Revit, because if you're getting this from a particular, this light fixture from a manufacturer, you want their real world lighting photometrics already built into it, inputted into this light source. There's no real need to create a light from scratch. You can just go find one, bring it in. And the nice thing about Revit, the way that Revit is working now that we're talking about lighting, is we're placing lights exactly how we want to see them in our design. So if you look up at the ceiling, you can see all the different light fixtures that are already in this room. You've got recessed can lights on the side that, hey, they actually added more light bulbs, I just noticed. We've got more light bulbs off to the side. You got a kind of up at the very front, a linear strip that's all the way across the front of the classroom. And then we've got 2 by 2 light fixtures that are in the grid, in the 2 by 2 grid system. And so what you're doing in Revit is you're just placing real world lights everywhere. And what Revit is doing is automatically placing all the photometric qualities of that light within the model, so that when you hit the render button, you don't have to adjust all of your light factors and all those things that you have to do in Rhino and V-Ray. You sit there and spend hours setting up your scene to make sure you don't have a hot spot somewhere, and you know, you're changing your light intensity of one, you know, light to the other, and you know, you probably spend, I don't know about you, but you could spend up to, you know, a couple hours, you know, just getting your scene to render correctly. But the way that Revit's working is it wants you to place everything how it's going to be in the real world, and then when you click on render, it should show you the result. And so obviously if you do a render and it doesn't look correct, that is kind of giving you real world feedback, telling you that you might want to add more lights into your space, you know, based on the light quality or the different fixtures that you're adding. So again, I'm not going to go into all those photometric qualities, just understand that those are there and you have the ability to change them. I'm going to load this into our project, and it'll give you something about, you know, wanting you to have a tag. I'm not going to worry about it. I'll hit no. And then I'm going to go into my ceiling plan and look at my grid. Now when I click on home to place lights, we're placing family components. So all we're doing is selecting a component, so under home and component, and then you should see under there that we now have our different light fixtures that were part of that family group. So you can see under lighting, ceiling light, linear box, I've got those three options, the 1x4, the 2x2, and the 2x4. So I'm going to pick 2x4, and then hover over my ceiling. You'll see that if I hover over at any space that doesn't have a ceiling, I'm not able to place it, and that's because lights are hosted components. They want to be hosted, not all lights are, but these particular lights want to be hosted to a ceiling. And so when I hover over my grid, the best way to deal with these is to place a light and then align it to a particular part of the grid. So I'm aligning it, and I don't have to lock it. You can if you want, but I'm, you know, aligning this grid or this 2x2 light fixture or 2x4 light fixture into the ceiling grid. Now if I were to move this grid, and let's say I decided later on need to move the grid over, my light is going to move exactly with that grid. It assumes it wants to be aligned to those particular grid elements. I'm going to Control Z because I actually liked my spacing there. But the other part is if I look at it in 3D and look at it from below, you can see I've, you know, it doesn't trim it out exactly, but you know, eventually we would, you know, when you render this, you'd actually see a light fixture there, and I'm going to have to show you some tricks when we get into rendering of how to make that work. But for right now, what you see is you've got the light placed in there, and you can also see that it pokes through, you know, the top of the ceiling. And if I were to take this ceiling and move it, let's say I decided my 15-foot height wasn't high enough and I want it to be 16 feet, and I move it, because the light is hosted within the ceiling, the light's going to move with it. So again, if I look at this in ceiling plan, and I might copy this light fixture every 8 feet, because that's how you might actually come across that in the real world. I'll just kind of copy this over and over real quick. I could have arrayed it if I wanted to. And then I might actually mirror this across the room. I've got these lights all over the place. And again, if I go in and move the height of the ceiling, all of my lights are going to move with it. So the nice thing is you can kind of start working with your ceiling or lighting design and what type of light fixtures you might want to show up in a rendering or even show up in a particular view, especially if you're looking at a reflective ceiling plan or even a 3D view. You know, again, if we were to take a 3D view and look at this, you might want to see those light fixtures. I also might want to go back into my user interface, and I'm going to open up that can light. Let's take a look at what that one is going to do. So downlight recessed can, and again, when I look at that, you can see it's an extruded couple of shapes, and it's got a different type of lighting definition associated with it. But I'll load in to the project. And then again, I can place this in the same manner by going to Home, Component. You know, maybe I'll add in some can lights. And you know, I might establish the first one so I can center it within the tile. I'll just place it and then use my dimensions. I might have to use kind of draw some temporary dimensions. I should be able to snap to the middle. You see that that did an equal equal. I'll do the same on the other side here. And get that where my light is in between the tiles, and then I can copy it around by, you know, selecting actual grid intersection points. Start to place all these can lights. You know, maybe I want some can lights down the middle of this space, and then mirror it. So then when we're looking up, you can see I've got the can lights in there. It's a little dark on the screen, but you can see, there we go, it's a little bit better. I've got my 2x2 fixture or 2x4 fixtures. I've got some can lights. And when I look at it in 3D from above, you know, I've got the actual can light, you know, sticking up above the ceiling, which that also helps with when you're looking at this in section. You know, eventually, you know, these lights are also modeled exactly how they occur in space, so that allows you in later coordination, when you start to have your floor structure up here, you've got your trusses, and then mechanical start to add in all their duct work, we can start to see if we have enough room to also add our lights, and then make sure our ceilings, you know, are at the right height as well, you know, by also looking at it in section. You can see we've got a pretty nice, you know, kind of interesting section happening when I look at this across the way. And then the last element here is to see how these lights behave in our sloped ceiling systems. And I'm going to look at a level 1. And in a system like this, I'd probably want to put in my can lights. So I've got a component can light. And once I've placed that, let me copy this. And look at it in 3D and see what it did. So you can see I got my can lights in there, and it looks like they are sloping. They actually slope with the structure, so that's kind of nice. Let me double check that. So yeah, you can see that the lights actually slope in the structure exactly with the ceiling as you go. So because it's hosted, it's going to do that, and if you wanted the lights to do something else, you'd have to create a light that wasn't hosted in the ceiling. And you know, I'm not going to get into that now, just so we can deal with this type of lighting at the moment. So I think for now, I've kind of gone over some more complexity with what we can do with ceilings. Start thinking about you know, skylights or any kind of additional daylighting, or even coming up with interesting ways of creating. You know, even you could take a quick vertical skylight or curtain wall system, and if you were to apply some kind of horizontal plane that would cut it, you know, you can start to get some interesting shapes of how you can slope it. You can start to see how we were able to do that, and then work with our ceilings and then lights, and how you'd start to close off all the different spaces, so that when you actually take a rendered view of this room or a section cut, it actually looks like how it would, you know, when it's built. For Thursday, I just really want you guys to keep working on your models. Just show me more progress. I want you guys to continuously develop it, because everyone's got, you know, different parts that you are working on. I can't really say, you know, everyone needs to have a pyramid skylight. You know, you might not have that condition. But what I'm going to be doing with all these classes from here on out is basically showing you other methods of working and what you might find that you could implement into your project. But the one thing that you all can do is start, you started working on your public spaces a little bit more. You might start thinking about what type of lighting, just real basic here, whether it's a can light or just a 2x2 fixture or a 2x4 fixture, what type of light you might start throwing into some of the spaces. You might start testing out some of these lights and placing them kind of like you would see as you walk through a building. You start to take notice that, in this room, these 2x2 light fixtures are actually, 2, 4, 6, they're, 8 foot on center. So 8 foot on centers across here. And then also your lights over there off to the left, your recessed cans might be something more like 6 foot on center. You might start to take notice of how closely lights are placed, because when you do renderings in Rhino and V-Ray, you kind of do the 3-point lighting system where you come up with just a couple 3 basic lights to flood the space and adjust the settings. And now that we're actually going to be placing real-world lights and trying to get some interior renderings, we really want them spaced. It's kind of how you would come across them in the real world. So start to take notice of that and start to add in at least some lighting into whether it's a room or into kind of like one of your guest rooms, your town share units, or one of your major spaces that you started working on. And I'll see you guys on Thursday. Yes?
Jeremy, can I ask you a question?
Let me get it.
Did you want to find out where? Yeah. Build a 30 by 60, 15-foot pool. Have that kind of stories in here. Imagine this.
So what we need to do is go to level 3.
Oh, that's fine.